Okay, so today what we are going to do is we are going to continue solving compound inequalities. Today is the 10th, okay? So compound inequalities. And we are going to just start off looking at some basic ones here. So we're going to look at how do we write a final answer for a compound inequality from a graph. So here's like our first example. Let's say I have this graph here. And I have an open dot and an open dot, and I have a shade in between. So the first thing I need to do is I need to write the compound inequality that represents this. So when I look at this, I don't have closed dots, so I should be able to identify that there's no equal to. That's the first part. And that I should start with 1, because we always write from least to greatest. So I start with 1, and 1 has to be less than x, or whatever variable you want. But my x has to be less than 2. And that should look familiar. Then what I want to introduce you to is another way to represent this. And that way is an interval notation. So for interval notation, we are going to use parentheses. And I'm going to write it over here. Parentheses are for less than or greater than. If I was to have an less than or greater than equal to situation, then I'm going to use brackets. And so this would be less than or equal to, greater than, or equal to. And again, this is called interval notation. Okay, so in order to write this, we only include the numbers that are included in our answer set. So this is less than, greater than, which means I'm only using parentheses. And I have the numbers 1 and 2. So I would write this as parenthesis 1, comma 2. There you have it. That is going to be my interval notation. So this up here is my set notation. And this here is my interval notation. So let's say we're going to look at another one of these. Let's say I have something that looks like this. And so when I have something that looks like this, I'm going to have 0, I'm going to have 1, I'm going to have 2, How about a -1 over here? And we're going to have a closed dot on 1, but an open dot on 2, and a shade in between. My negative sign doesn't look very good. Okay, so then if we were to write this as a set notation, I can see that my x is in between these, or my variables in between these two. 1 is going to be less than or equal to my variable, which is less than 2. This is my set notation. Then I'm going to look at what my interval notation should be. Now, because this is x is greater than or equal to, that means that on this side, I'm going to have a bracket, not a parenthesis, and this is going to be 1, 2 with a parenthesis. So you will see that I have a bracket. The bracket represents the greater than or equal to, and the parenthesis represents the less than. Okay, so that is what set interval notation looks like. This is interval notation. Okay, and then the only other thing we might see something that we need to know. Let's say I have a graph that looks like this. Again, I have 0, I have 1, I have 2, I have -1. I'm going to say that I have an open dot on 1, and I am going to be shading to the right. So I got something that looks like this. Now, I need to write the inequality for this. So I know that x is going to be greater than 1 because I'm shading to the right and 1 has an open dot. Pretty straightforward. So this would be my set notation. Now, if I need to write an interval notation, what I'm going to do is I'm going to look at this again. I have parentheses because it's not a closed dot, and my parentheses are going to start at 1. I don't have a second number here, but I should know that this arrow indicates that this goes on forever and ever and ever. So the second number here is going to be this symbol, which represents infinity. Like it's just going to keep going. So as long as it is greater than 1, it could be any number. And that's how we would represent that as a interval notation. Okay? So that is just kind of some of the basics of, again, proper ways to write an answer. Now we're going to take a look at how do I write an inequality from a sentence. So let's say I have a number D is more than 0 and less than 10. Okay, so here we go. A number D. So that is showing me that D is my variable. So when I write this, I need to make sure I use the correct variable, right? I can't just use something else because it identifies what it needs to be. Is more than 0. So is more than 0. Okay. So D is more than 0. This can also be written as 0 is less than D. Either one of these represents this sentence here. Okay, these two correlate. And so D has to do two things at once. This and lets me know that this is going to be a compound inequality. So this is telling me compound. Okay. And then I have over here, it's telling me less than 10. So I would need D to be less than 10, or I know 10 is greater than D. These are both ways to identify this portion of the inequality. Then when we look at this, we know that our inequalities need to be written from least to greatest. So I need to identify a 0 or 10, the larger one, and out of 0 and 10, which one's the smaller one? So I'm hoping we can identify that this is the smaller one, right? 0. So I need to have it written as 0 is less than D. And since D has to be in the middle, I'm going to have to use it written this way, and D is less than 10. And then I go back and I reread. A number, D, is more than 0, showing it's greater than 0, and less than 10. Here you go. I have written this compound inequality. Do I have any questions?
Miss Shaw,
Yes.
do you have to like write down like if D is more than 0, do you have to write down like D is greater than 0, and then to the right of that, do you have to write down D is less than 10, and then the bottom step you have to put together, but you have to do the step in between?
No, you do not. These are for notes. And so I want to make sure that we understand like how we got from reading this to this. Does that make sense?
Yes, thank you.
You're welcome. So I'm showing you all the steps. Some of you will be able to read a sentence and write an inequality. Some of us need to include some extra thinking. Okay? Okay, here's my next example. This is going to involve some more writing. I apologize, but since I'm not in class with you, I can't hand you a worksheet. So, the local zoo waives its entry fee for children age 3 and for seniors age 65 and older. So we are going to write two separate inequalities for this, but then graph them on the same line.
Miss Shaw,
Uh-huh.
maybe you can clarify what waves mean?
Yeah, totally. So waves means that it like doesn't make it it doesn't make it necessary. So like if I waive the fee, I'm gonna not make you pay it.
Like you don't have to pay.
Yeah, like you don't have to pay. So if I'm going to the zoo and I have a kid who's under the age of 3, I don't have to pay for them. Or if I have a senior with me who's 65 or older, which by the way, 65 is not very old. So anyone 65 or older doesn't have to pay. Okay, so what we're going to do is we're going to look at this and we're going to try to come up with an inequality that represents this, and then we are going to graph it on a graph and determine what customers the zoo charges the entry fee for. So my first inequality is for children age 3. Children age 3. That doesn't make sense, so I left out a word, under. There we go. So its entry fee waives the entry fee for children under age 3. So here's a child, and if my child is under age 3, this child's going to get in for free.
Is it greater than or equal to or just under age 3?
So for children under age 3.
So it will be less than.
And then it says, and for seniors age 65 and older. So if I have a senior and they are older or equal to the age 65, they're getting in for free. Because it says seniors age 65, so they can equal 65 or they have to be older than 65, and they're getting in for free. So those would be my 2 inequalities. And then if I was to graph these on a number line, here's 3, here's 65. 3 is going to be an open circle. And should I be graphing to the right or the left of this?
Left.
Left.
Okay.
And
then here I have an equal to, so this is a closed dot. And should I be graphing to the right or the left?
Right.
Right.
Okay. So now let's take a look at this. Yes.
Shouldn't it stop at 0?
I'm sorry?
Shouldn't C is less than 3? Shouldn't that technically stop at 0?
Yeah. I mean, no one's going to be less than 0, but I don't personally feel the need to write that down because I just know that people don't exist under that age. Like, okay. So when I look at this, does this graph really help me to determine who's buying tickets into the zoo?
No.
Okay. Why is this not helping me determine who's buying tickets?
The graph represents the people that are younger or older than a certain age that don't need to buy tickets. So it represents people that don't need to buy tickets.
So this is a graph don't need tickets. So how would I graph this in order to show who is buying tickets?
You make a segment between 3 and 65. 3 has a open dot, 65 is a closed dot.
Well, let me ask you this. It says seniors age 65 and older don't have to pay.
Oh, so it would be the opposite. The 3 will be a closed dot, 65 will be an open dot.
And then everybody in between, this represents who needs tickets.
Miss Shaw,
Yeah,
can you clarify why 3 is a closed dot?
because it says that you have to be under the age 3 to be free. So if I have a 3-year-old, that kid has to pay. So it depends on what the question's asking, right? So if this question asks me who's paying to get into the zoo, a 3-year-old's paying all the way up to the age 65. But when we hit 65, you're free. Okay? If you're on the other side of this, you're free.
Okay, thank you.
You're welcome. Okay, any other questions? Everyone feeling okay about this? We can write some inequalities to solve and whatnot.